214 and 215 of the Sarkin's textbook, okay? So let's first talk about the situation, okay? The situation is that they took, a sample of Alzheimer disease patients. Am I correct? Okay. So there were two conditions, right? Okay. The first condition is just helping them with visuals, right? And then the second condition is basically the patients were taught using visuals and verbal rehearsals, right? There are two conditions, okay? With me so far, okay? So now we are simply, in this case, we are simply looking for a difference. Difference, right? Okay? All right. Now let's first talk about this. So on 215, okay, there is a table of scores. With me so far? Okay. Group 1 and Group 2, right? Visuals versus verbal rehearsal, right? Am I correct? Okay. The first question, are those groups independent or dependent?
Independent.
Independent, very good, excellent. Independent, right? Which means that, okay, one person cannot be in both conditions. One person has to be one and only one condition. With me so far? So those groups are independent. With me so far? Number 2, do we know population parameters?
We can.
Do we know population parameters? No. No. We don't know. Right? We don't know. We do not know population parameters. There is no population parameters here. Okay? Therefore, we can't use z-test. Z-test requires you to know population parameters. Remember? Okay? Mu and sigma, right? We don't know. So we can't use z-test. We have to use a different test. With me so far? A statistician named William Gossett, okay, who was working for a Guinness brewery. Do you like beer? Okay, that Guinness brewery. That's a true story, okay, at the turn of the 20th century, okay? What he was doing was basically a quality control thing, right? Quality control, okay? Picking 5, or 10 small number of samples, repetitively, right? Okay? And then basically calculate the mean of the volume, okay? Because of course he didn't have the population parameters. There was no way for him to actually use z-table, okay? Z-scores. Z-test, z-test, right? Probabilities were different. So he came up with a formula, modified z-test, okay? But Guinness Brewery employees were prohibited from publishing their findings with their real names. So he used the pseudonym, student T. Then it's called a t-test. What is t-test? when the sample size is small, which means degrees of freedom is small, right? It's flatter, right? As the sample size becomes bigger and bigger, what do you think is going to happen?
It will be less flat.
Yeah, exactly. Exactly. If the sample size becomes infinity, what do you think is going to happen?
Just keeps
Almost
going
a
up.
straight line. Well, it gets really tall.
It just keeps
Which
going.
means what?
Oh, it gets
T becomes
zero.
Z, exactly.
Yeah.
Excellent. T becomes Z. Exactly. Do you have the first textbook? I mean, the research method text. No? Okay. If you have, would you please share? Would you please share it?
Yeah, sure. Come on, share.
Please open page 445. Would you guys please take a look at it? Okay? You can look at it.
Okay.
Come here. Come here.
Page 4.
You. Come here. Page 445. Okay? Come here. Page 445. Okay? Okay? Now, Z score, right? Okay? T score, right? Distribution of T. Are you looking at it? Okay. Okay. Now, look at, okay, level of significance for 1/3. Okay? 1/3. Are you looking at it? Okay. Now look at 0.05. Right? T score is getting smaller and smaller as the degrees of freedom or sample size becomes bigger and bigger, right? And then at the end, okay, when the sample size, when the degrees of freedom is infinity, okay, T score is 1.645. That's exactly the score of Z. Do you remember that? So the whole point is T value, okay? T distributions are when sample sizes are small, right? When we use that,
So,
okay?
like,
And
for our research project
T
for this
test,
class,
yes.
T-test,
Yeah, T-test is used. There are so many other techniques, but
Yeah.
this is the first one. The first technique you have to learn. With me so far? There is something called degrees of freedom. Degrees of freedom, okay? Because we have two groups, right? Two groups, okay? Okay? From each group, you have to subtract 1, right? Just like the denominator of a variance, remember, n minus 1, right? Okay? You have to do n minus 1 for two groups. Twice, right? Which means this is called degrees of freedom, right? The sample size minus 2, okay? Okay? Of course, SPSS gives you the whole, numbers, but okay. Hypothesis. With me so far? We don't know population parameters, right? Okay? But we have two groups, right? With me so far? Then, what do you think is the best point against which we should compare? What's the relationship? we are comparing two groups, right?
The mean?
Yeah, two means, exactly, two means, right? So then, what would be the best null hypothesis?
You mean if group one is not equal to the mean?
Exactly, exactly, equal to. Excellent, exactly. No difference, right? Exactly. With me so far? That's the best point against which we should compare. Okay? Without knowing population parameters. No difference. Right? And then of course H1 is the complete obverse. Okay? Obverse of HO, right? Am I correct? Okay? Let's do a little bit of an arithmetic operation. Okay? Then mu1 minus mu2 should be 0, exactly. Do you understand what I'm doing? Right? Mu1 minus mu2, I just shifted mu2 from right to left. Right? So mu1 minus mu2 equals 0. That's the null hypothesis. Then mu1 minus mu2 is not equal to 0. Is this two-tailed test or one-tailed test? Two-tailed test, exactly. Excellent. Very good. Right? And here is the formula for t-test. Whatever, I don't care. SPSS gives you numbers, so who cares, right? Correct?
If you say so.
Yes, if I say this, I'm right. Okay. All right, so remember, looks like the format itself is kind of similar to z-test, right? Don't you think? The difference, right? The difference between a sample statistic and the population parameter, right? With me so far, and then divided by a standard deviation of the distribution. With me so far, it's still similar. So I have been emphasizing that no matter how complex a formula becomes, it's always this. Okay? A difference between a sample statistic, and the population parameter divided by the standard deviation of that distribution. In this case, t. With me so far. Now we are testing this one, right? The null hypothesis, am I correct?
Yes.
Then what is going to happen to this formula?
The mu1 minus mu2 becomes 0.
Exactly. Excellent. This is t-test. Independent samples t-test. Okay, the language you have to use is this. Independent samples t-test. In this case, two-tailed test. With me so far. Very good. Hannah, very good. Exactly. Population parameter becomes 0 because we are testing this one. Right? With me so far? So, this is a test we are doing. Remember, we don't know population parameters. Okay? we have two independent groups, which means that one person belongs to one and only one group. Does it make sense? This is called independent samples t-test. In this specific case, we are looking for differences. Therefore, it's two-tiered test, not one-tiered. Okay? With me so far.
Isn't it 30?
60.
Which one do you think?
60 in,
20?
do you mean the population or in the sample?
No. Sample. This is sample.
Oh, 60.
60, right?
Yeah.
With me so far? So you have to first type 60 for the first column. With me so far? Okay. Remember to type case numbers. Okay? Case ID first. Right? If you make a mistake about this point, then your data organization is kind of screwed up. With me so far. But if you get it correctly, then your data organization is correct. Okay, so I want you guys to jot down independent samples t-test. With me so far? Okay? Why do we call independent? Because those two samples are independent. Okay? So, when you have two independent groups, right? Two independent groups, like men and women, okay? Or undergrad and grad, two groups. And then the dependent variable is continuous, right? Like scores, exam scores, right? Or Likert scale, right? Continuous. Then you can use independent t-test to compare two group means with me so far. Okay?
Dr. Hussein,
Yeah.
I know I asked you this during break, but if you have one group that you test twice.
Yes, that's the next
Okay.
step. Don't worry about it. We are going to discuss it. Okay? 60 people. Okay? So 60 scores. Am I correct? Is this enough?
No,
Why not?
we need to make distinction.
Huh?
We need to make a distinction between this.
Yeah, you have to separate those 60 scores into two groups. Am I correct? What should we do then?
So this will be
Exactly, 0, 1, right? So we have to create a new variable next to exactly already Hana is doing that, right? So 0 represents group 1 and 1 represents group 2. Exactly. That's how you should organize data for independent samples. Right? Independent samples. With me so far? Okay? Excellent, Hannah. Now, let's define variables. Exactly. Now, let's call it ID, name, ID. Okay? And then the second one, what's the score? Words. How about the words? Okay? Words. And then the third one should be group. How about that? Right? Okay. Case ID. The number of words remembered. Words remembered. Okay. And then group, treatment groups. How about that? Treatment groups. Okay? And then treatment groups must be defined. value 0 means visuals. Visuals. 1 means visuals and verbal rehearsals, right? Excellent. Thank you.
You're welcome.
Very good. Data view, and then let's save it. Okay. Desktop. Okay. Say T. Oh, independent T. Yeah, T independent. That's fine. Okay. Save it. Yeah. Okay. Let's go back. Okay. Now from here, first you have to run descriptive statistics. Am I correct? Let's run descriptive. Okay. Number of words and the treatment groups. And then statistics, all of them, mean, median, mode, skewness, okay. Skewness, kurtosis, and standard deviation, blah, blah, blah. Okay. All right. And continue, and then charts, histograms, and show normal curve. That's fine. Show normal curve. Okay. Okay. Hit okay. Right? Okay. Now we have this one, right? Okay? Frequency tables, right? Okay. As you can see, we have 30 cases for each group. You know? So we entered the data correctly. A little bit skewed. Okay? But we can do more tests by using select cases, right? For both of them. Okay? But for the sake of discussion, we are going to skip testing normality assumptions. Okay? Okay, very good. Now, from here, there is a real inferential statistic. Okay? Now, Hannah, would you please go to analyze? Very good. And then, which one should we use?
What are you trying to do?
Basically, we are doing what? We are testing
Do you want?
two groups, right?
Oh, yeah.
Okay, so just no. Can you cancel? Okay, let's go to analyze. So there is a huge list, right? When you look at this, which one is the most appropriate?
Compare means.
Exactly.
Oh, look.
Yeah, I said that too.
Exactly. Compare means, right? And then compare means and which one?
Independent.
Independent separate status. Exactly. And then test variable should be number of words, and then
No.
Treatment groups are grouping variables, right? With me so far? And then please,
Oh, over here.
yeah,
There we go.
right? And then you have to define groups. Group 1 is 0, 0. Group 2 is 1. With me so far? What it means is that, okay, SPSS is subtracting scores, okay, of group 2 from group 1. Right? That's the operation. Okay? That's the operation. Okay? So, okay. This is the t-test. Very good. Thank you for doing that. Okay, from here I can take it.
Okay.
Excellent. Thank you.
Oh, you are so welcome.
Thank you very much.
Put my data in.
Does it make sense? Okay, now there are several assumptions we have to make when using t-test. Okay? The first one is independence or randomness. Okay? When we apply random sampling, simple random sampling, then we can assume that each case is independent from each other, right? So selecting one case doesn't affect selection of another case. Does it make sense? That's called independence. Independence. Okay? Number 2, normality of each, okay? Normality of each group's distribution, right? So technically, we'd better do select cases and actually run, okay? Actually run frequencies. With me so far? So normality of dependent variable for each group, right? In this case, 30, okay, group 1 and group 2. So technically, it's better for us to actually select cases, 30 and 30, group 1 and group 2, and then run frequencies to see the shape. Does it make sense? Okay, but for the sake of efficiency, I just skipped the process. Give me some. Number 3, the first, okay, you have never heard this term, right? Homoscedasticity. Homoscedasticity means homogeneity of variances. Two groups' variances are the same. That's the assumption we have to make. Okay? Two groups' variances are the same. Okay? That's the assumption we have to make. Then the assumption is tested in SPSS. With me so far? Okay? But SPSS just gives you, okay, two versions of a test, two versions of the independent simplicity test. Okay? One is for a situation in which we can't assume variances are the same. The other one is for the situation in which we can assume variances are the same. With me so far? Okay. Let's look at this. So the first one, okay, visuals versus visual and verbal rehearsals. So case size are 30 and 30. The mean is 5.43 and 5.5333. With me so far? Standard deviation is this different. 3.42 and 2.06, which means that variances are different, right? The question is whether the difference is significant or not, right? The difference in variance. Standard deviation is simply square root of variance, right? With me so far? So, the first group has the standard deviation of 3.42 or 86. The second group has 2.06336. With me so far? And then SPSS tests this assumption, whether we can assume those two variances are the same or different. With me so far? Okay? Levin's test. Levin's test. With me so far? I wish SPSS just changed this, but people are confused about this, organization. Actually, those two columns should be here, because those language applies to t-test. With me so far? This part is simply testing this assumption, right? So I know it's confusing. Okay, on behalf of SPSS, I apologize to you. But the whole point I'm making here is that this part should be separate from here. With me so far? Okay? This part is simply testing this assumption. With me so far? Levin's test. To see if those two groups' variances are the same or different. Okay? And then Levin's test is something called F, but we are going to discuss later. But the most important one is this significance level. 0.029. Is 0.029 larger or smaller than 0.05? Smaller. With me so far? Smaller. Then what decision do we have to make?
It's insignificant.
Exactly. Levin's test simply compares variances. Okay? Variances. With me so far? This is Levin's test, which is testing one of the assumptions. With me so far? Why do we have to test assumptions? Because unless we satisfy assumptions, we can't use a certain statistical test. With me so far? Okay? So this is a set of hypotheses Levin's test is testing. With me so far? Okay? Now we got 0.0229, right? Okay? 0.029. What decision should we make? Reject the null hypothesis. Exactly. Exactly. Once we reject the null hypothesis, then we can't assume variances are the same, right? Because there is sufficient evidence to conclude that the variances are not the same. Correct? Then we look at those two rows. Right? The conclusion is that given this data set, we cannot assume those two variances are the same. Right? So which rows should we use? Top or bottom? Equal variances assumed?
No.
No.
Bottom.
Exactly bottom. Equal variance is not assumed. With me so far? So you have to look at this row, the bottom row, not the top row. Think this way. This Levin's test of equality for Levin's test for equality of variances is here. Here, okay? With me so far? Right? This part is here. Okay? Then based on the Levin's test, then you have to make a decision. Which version of t-test you should use? In this case, the bottom one. With me so far? Because Levin's test is showing significance, which means the null hypothesis must be rejected. Right? Therefore, variances are not assumed equal. Okay? So this part, right? Okay? This bottom part. Okay? And then this is how you write. Okay? DF means degrees of freedom. Okay? So 47.635. With me so far? That's the degrees of freedom. Equal negative 0.137. Right? P means calculated value. Okay? Calculated probability. In this case, 0.892. With me so far? 0.892. Right? Okay? Do you see this language, two-tailed test? Two-tailed test. That's exactly what we are doing, right? Two-tailed test, okay? So based on two-tailed test, okay? The probability of this t-value is 0.892, right? Which is much, much higher than 0.05. Therefore, what would be your decision? Reject. Reject. We have failed to reject the null hypothesis, right? Okay. So, calculated p-value is much, much higher than 0.05, right? 0.05, which is alpha, significance level, right? So, the null hypothesis cannot be rejected. Cannot be rejected. Right? So, okay, there isn't sufficient evidence to conclude that, okay, either one of the methods is more effective than the other. Conversely, okay, whether you use verbal only or verbal and visual doesn't make any difference. Does it make sense? This is how you have to make decisions in the real world. Instead of just looking at descriptive statistic. Right? Like, oh, men have a higher score on average, so is this really statistically significant to take it seriously? Or it's just by chance? The language, by chance. If the result is simply by chance, then what's the point of taking the result seriously? But as you already know, in the real world of business, they just take the results by chance and take it seriously, and based on which they create a marketing plan. No wonder 50% of new products fail, right? Do you understand what I'm getting at? Let's read slowly, okay? Together. The independent variable is the program type designed to help Alzheimer's patients. Group 1 was taught by visuals. Am I correct? Group 2 was taught by visuals and intense verbal rehearsals. The dependent variable is the number of words each patient remembered following a program. Because this question focuses on any difference between the two groups in terms of the number of words remembered by the patients, a two-tailed independent samples t-test must be used. Do you understand this language? Because the difference, right? Not either one of them is bigger than or lower than, okay? Therefore, we have to use two-tailed test. The null and research hypothesis are as follows. Right? So the null hypothesis mu1 minus mu2 equals 0. The means of the two groups are not different. Mu1 minus mu2 is not equal to 0. The means of the two groups are different. Because Levin's test for equality of variances shows a statistically significant result. Okay? You don't have to worry about this. Just p-value. Okay? Just p-value. P equals 0.029. Right? Equal variances between group 1 and group 2 cannot be assumed. Am I correct? Cannot be assumed. Right? Therefore, we have to use something called separate variance t-test, which means equal variance is not assumed according to SPSS. Right? The bottom version of t-test must be used. The mean difference between group 1 and group 2 is 0.10. Right? Because the p-value is greater than alpha 0.05, right? Calculated p probability, okay? Calculated probability associated with a t-value, okay? T-value is this one. Is much much larger than 0.05, the null hypothesis cannot be rejected. Right? Cannot be rejected. In other words, the difference between the two group means is not statistically significant. Therefore, the data doesn't provide sufficient evidence to conclude that the two treatment groups are different in terms of their effectiveness. This is the language, okay? The language, okay, you have to use to interpret SPSS numbers. If you look at this numbers, okay, numbers are just numbers. Don't mean anything. The question is how you can verbalize it. Okay? Verbalize your finding. Does it make sense? So, Claire asked me the question. Okay? So, of course, we are dealing with, in this case, we are dealing with two-tailed test. But of course, there are one-tailed test. Okay? Version of one-tailed test. Okay? Higher or lower. With me so far? So this, if it's one-tailed test, okay, this is how you write. With me so far? And then an independent sample t-test must be used when two independent groups are involved. Okay. Levin's test for equality of variances examines one of the assumptions that an independent sample t-test must satisfy. Okay. If Levin's test shows the p-value lower than 0.05, which is in this case, okay, which is in this case, the null hypothesis of equal variances should be rejected. Right? That's why we use the bottom version of t-test, which doesn't assume variances are equal. With me so far? Now, here's a little bit of difficult part. Okay. This is two-tailed test, right? Probability. With me so far? This probability, okay, is since this probability is based on a two-tailed test, okay, the probability is basically combining both sides. Okay, the probability, okay, associated to, okay, the area above plus 0.137 and minus 0.137. With me so far? Unfortunately, SPSS gives you only two-tailed. Right? What if this test was one-tailed? Who said that?
Jazz.
Wow.
All the extra credits.
Did you hear that?
You heard it.
Did you hear that? Divided by 2. Exactly. Because if this is the case, then we are just talking about this side, right? Right? So this is the calculated p-value, which is an addition of two probabilities. That's why we did this exercise. Remember how to subtract, how to add. Okay, so what you spent, the time you spent into understanding probabilities is not a waste. This is exactly the point. Reaching to this point is one of the goals, right? So remember this. If your test is one-tailed, you have to divide it by 2. That's the probability. Right? So if this is the test we are doing, okay, we have to divide this probability by 2. Right? So one tail test is 0.4. This is one tail. Okay, Jasmine, how did you know about this? You took, okay, module 10. I want you guys to download and then read this interpretation as an example. Okay? This should clarify what we are doing.
Module 10.
With me so far. This is called independent samples t-test. Okay? Independent samples t-test. In this case, 2-tailed test. Okay? But remember, there is 1-tailed test too. Okay? There is a possibility.